We're going to go over these questions from the 7.4 to 7.5 quiz review. We have multiplication of radicals and dividing radicals. So we will start with this number one. So when we come across the multiplication problem, we can simplify radicals first sometimes. So square root of 5 does not simplify, but square root of 4 we know is just 2. So we can write negative 5 root 5 times 2. And we're just multiplying across here. Remember, when we have a value on the outside of a square root like this, it's really just times. And we can multiply in any order. So we can actually do 5 times the 2. So negative 5 times 2 is negative 10 root 5. And that's how we leave it. Over here, a couple different ways to do this. The square root of 20 we can simplify. So we think of 20, we've seen 20 a lot. 20 is 4 times 5, and 4 is 2 times 2. So 20 is the square root of 2 squared times 5. So we've got negative root 5 times negative, and we can bring out a 2. The square root of 2 squared is 2 root 5. And now we're multiplying. So we have a negative times a negative, which is positive. We have a 2, and then root 5 times root 5 is simply 5, because we know a square root times itself is whatever's inside, and we get 10. That's our first thought on there. If you're familiar with multiplication, you know 5 times 20 is 100, and 100 is 10 squared, so the square root of 100 is 10. So we could have thought of it that way. A negative times a negative is positive. So we have 5 times 20 is 100, and the square root of 100 is 10. So there's 2 different ways to think through that one. Number 3 and 4, looks like we have to distribute here for both of these. First, we do want to check under our square roots. Can we simplify anything? And we can't in this case to start with, so we're going to distribute. So we have 3 root 10 times root 2. That's 3 root 20. We multiply the 2 things that are under the square root, and then we do 3 root 10 times 3. So we have plus, and then 9 root 10. Once we multiply, we look at what we have and see if we can simplify any radicals. We can now simplify. We have a 20 again, so we remember 20 is 4 times 5. So we got 2, 2, and 5. So the square root of 20 is really the square root of 2 squared times 5. Square root of 2 squared is 2, but the square root of 5 we can't simplify, so that stays within the square root. And so over here we have 3 times the square root of 20, which we found was 2 root 5. So we're replacing this with 2 root 5 plus 9 root 10. 3 times 2 is 6, so 6 root 5 plus 9 root 10. And that's the answer for number 3. Similar question over here on number 4. We can't simplify root 15 and we can't simplify root 10, so we're going to go ahead and multiply, and we get the square root of 150. And then we distribute the root 15 to the 3, so plus 3 root 15. Now we look at our radicals, see if we can simplify. Root 15 we already know we can't simplify, it's just 3 times 5. But 150, we can factor that. First we might think there's different ways to factor this, but I would probably do 15 times 10, which we have a 3 and a 5, and a 2 and a 5. And so 150 is the same as 2 times 3 times 5 squared. And so when we're taking the square root of this, this is 2 times 3 times 5 squared plus 3 root 15 still. And we can't simplify the square root of 2 or the square root of 3, but the square root of 5 squared is simply 5, so that comes out here. 2 times 3 is 6, so we have 5 root 6 plus 3 root 15. Nothing left to simplify, so that's our answer for number 4. Moving on to the next slide. More distributive property. We can think of FOIL here, or FOIL is just a special way to remember the distributive property. So we have our first terms multiplied together. Actually, I should mention we can't simplify root 3, so there's nothing to simplify in our square roots to start with. So now we will multiply negative root 3 times root 3, which is negative. You can think of this a couple different ways. 3 times 3 is 9, so root 9. You also might think, well, root 3 times root 3 is just going to be 3. That's great that you know that. Negative root 3 times negative 5 is going to be positive 5 root 3. And now we'll do the 2 here, 2 times root 3. And 2 times negative 5 is negative 10. As mentioned earlier, this is just the square root of 9 is 3, so we got negative 3. Well, we have a couple like radicals that we can combine here. 5 root 3 plus 2 root 3 is 7 root 3 minus 10. And in fact, we have some integers we can combine here. So we have negative 13 plus 7 root 3. Number 6, looking through number 6, the radicals in number 6, we cannot simplify the square root of 3 or the square root of 2. The square root of 4, well, we know that. That's just 2. And then plus 2 root 2 does not simplify. I'm going to go ahead and rewrite this. You might not need to, but just to have it so not something's crossed out there. 2 plus 2 root 2. Now we can't simplify any of this stuff, so we go ahead and multiply. 5 root 3 times 2 is 10 root 3. You multiply the thing that's not within the radical, nothing to multiply root 3 with. Multiply these. 5 times 2 is 10. Root 3 times root 2 is root 6. Next one, 2 times root 2 is just 2 root 2. And the last one, 2 times root 4. Because we have the 2 and the root 2 times root 2 is 4. We do know that this root 4 is just 2. We can rewrite this as we move through. We don't have any like radicals here. And if we think through this, we have a 2. The square root of 4 here, let's just do it in a different color. This we know is 2. So we actually have 2 times 2 is 4. So this final term here is 4. And once again, we have no like radicals. So this 4-termed answer is what we want. Number 7 and following have to do with division. We have a couple things to think about when dividing. We don't want a square root in the denominator. So a couple different options here. First thing we want to look for is, are there any perfect squares? Like the square root of 4, or the square root of 9, or 16, or 25, or whatever. So looking at this one, we could reduce first 20 and 64, but better yet, we know the square root of 64 is simply 8. So we got the square root of 20, square root of 64 is 8. Start with that. So a quick glance, we know square root of 64 is 8, which is good because now we don't have a square root in the denominator. And now we look at the numerator, we see square root of 20 once again. We saw that in a couple other questions. 20 is 2 times 10, which is 2 and 5. So 20 is 2 squared times 5. And so we can think, well, we got the square root of 2 squared times 5 over 8. We can bring out a 2. So we have 2 root 5 over 8. But we're not finished because we have 2 and an 8. Neither of our within a radical, so we can simplify those. 2 goes into this once, and 2 goes into this 4 times. for a final answer of root 5 over 4. Next one, once again, look for perfect squares. We know the square root of 25 is 5, so we have the square root of 8. Square root of 25 is 5. 8, that can simplify. That's 4 times 2, which is 8 ends up being 2 cubed. And so we can think, well, we got square root of 2 cubed over 5, which really is the square root. We're going to split this up into perfect squares. We've got 2 squared times 2 over 5. And then our answer, square root of 2 squared is simply 2. Still have a 2 left within the square root over 5. So in those cases, we could have simplified a square root first. Moving on to the next ones. Number 9, once again, we have a perfect square here. So this is really just the square root of 4 is 2. So right off the bat, we have 10 over root 5. But we remember that we cannot keep a square root in the denominator to have it in simplified form. When we just have one term down here, no plus or minus, we can simply multiply by a form of 1. And what we want to do is we want to do the square root of 5 over the square root of 5. Again, the reason we do that is because we don't want a square root in the denominator. So the square root of something times itself is simply just that number. So here we have a 10 root 5 in the numerator. In the denominator, root 5 times root 5 is 5. We're not quite finished yet. Now, just to mention this, 5 does not reduce with 5 under the square root. You can't simplify those. They're not common factors because the square root of 5 is between 2 and 3. But 5 and 10 do reduce. 5 goes into 5 once, and 5 goes into 10 twice. So we're just simply left with 2 times the square root of 5. Number 10 is the first time we're seeing this concept that I'll show you. First of all, we see we have this 3 in front of the square root and a 2 down here. You check if they reduce. In this case, they don't. 3 and 2 don't reduce. But we can also do the same thing within a radical, as long as it's just no addition in both the numerator or denominator, no addition or subtraction. We notice here that 3 goes both into 15 and 6. 3 goes into 15 5 times, and 3 goes into 6 twice. So after that simplification, we have 3 root 5 over 2 root 2. Now this still is not a proper form because we still have a square root in the denominator. There's no addition or subtraction here, so we really just need to take care of this root 2. This 2 right here is fine. We're allowed to have a 2 in the denominator, but we need to multiply by root 2 over root 2, because when we do that, a square root of 2 times the square root of 2 is simply 2. So in the numerator, we have 3. Root 5 times root 2 is root 10 over 2. And then the square root of 2 times the square root of 2 is 2. And so we have 3 root 10 over 4. You might think, can I reduce here? 3 and 4 don't reduce. 4 and 10 cannot reduce. 4 is not within a square root, and 10 is, so you can't reduce those. Moving on to some ones where we actually have binomials in the numerator. Number 11 is going to be quick because we look for perfect squares, and the square root of 9 is simply 3. And the numerator, we can't simplify anything up there right now. So we have 4 plus 3 root 2 over 3. And that's going to be our answer. There's no square root in the denominator, so that's good. We can't simplify this 3 with anything. When we do check, the 3 would have to simplify with both terms. since we have addition or subtraction up here. You can't just cancel a 3 with a 3. These cannot simplify because 3 doesn't go into this one evenly. Moving to number 12, 4 root 3 plus 5 root 5 all over root 10. There's no simplifying we can do within our radicals to start with. We're not allowed to have a square root in the denominator, so we're going to use the same strategy we did on, I think it was 9 and 10. We have to multiply top and bottom by the square root of 10. We do that because the square root of 10 times the square root of 10 is just 10 in the denominator. So we have 10 in the denominator, and then the numerator is just a multiplication problem where we have to distribute. So we have root 10 times 4 root 3. Well, we have the 4 here. 3 times 10 is root 30. Plus 5 root 5 times 10. Well, we have the 5 out here. And then 5 times 10 is root 50. We need to see if we can simplify these radicals. Let's check 30. 30 is 5 times 6. 6 is 2 times 3. 2 times 3 times 5, there's no perfect squares in there. There's nothing squared, so that's not going to simplify at all. 50, however, is 5 times 10. And 10 is 2 times 5. So 50 is 2 times 5 squared. Well, we can simplify that. So we have 4 root 30 plus 5 times, well, 50 is 2 times 5 squared, all over 10. And this simplifies. A 5 can come out. So we have 4 root 30. I'm going to throw in an extra step here. We could do this in one step, but I'm just going to show you. We have this 5 out here. But then we can bring this 5 out also. So when we do that, it's multiplication. So the square root of 5 squared is 5. That comes from this. Can't simplify the square root of 2. And so this is still all over 10. And we can realize 5 times 5 is 25. So we have 4 root 30 plus 25 root 2 all over 10. And we want to look to see if we can reduce anything. There's no square roots on the bottom to reduce with 30 or 2. 4 and 10 reduce by 2, but 25 does not reduce by 2. So we can only reduce if all 3 terms can be simplified by the same number, and they cannot. So this fraction here is our answer for number 12. (13) and 14, bringing a new aspect. Now we have a binomial in the denominator. Binomial in the denominator, we can't just multiply by root 3 over root 3. That's what we could do if there was a monomial or single term in the denominator, like that one and this root 6, which ended up being a root 2, or this root 5. But we cannot do that when we have 2 terms. So what we learned here is if we multiply the whole thing by a form of 1, and the form of 1 we want is we want to use the conjugate of this binomial here. The conjugate means we are just going to change the sign between those two. So 2 minus 4 root 3 over 2 minus 4 root 3. So that's the new concept to know. The rest is just multiplying out, which we've learned and worked with already. So in the numerator, this 3 is going to be multiplied by this binomial. So 3 times 2 is 6. And then we have a minus. 3 times 4 root 3 is 12 root 3. In the denominator, we learned if we multiply a number by its conjugate, it's going to be the first number squared, so 2 squared, minus the second number squared, 4 root 3. You need to put parentheses, that whole thing squared. We know that, I'll mention this once, we know that because when we learned factoring, we learned that a plus b
times a minus b is actually just equal to a squared minus b squared. And that's exactly what we're doing. We're taking a number, two terms, a binomial, and multiplying it by its conjugate, so changing the sign in the middle, and this will be a squared minus b squared. And that's what we're doing here. So when we do the conjugate here on the bottom, I'm always just going to do the first thing squared minus the second thing squared. So back to our problem. In the numerator, we have 6 minus 12 root 3 over 2 squared is 4 minus, can probably do this in your head. If you need to do it to the side, that's fine. But when you square two things multiplied together, you have to square both of them. So 4 squared is 16, and root 3 squared is simply 3. And 16 times 3 is 48 if you multiply that out. So this is 48. So 4 minus 48 is negative 44. That's in our denominator. Now this is a case where we notice in each term 2 goes into 6, 2 goes into 12, and 2 goes into 44. And so when that happens, if the same factor goes into each term, not what's under the square root, but out here, then we can reduce by that. So we'll take 6 divided by 2 is 3, 12 divided by 2 is 6, and 44 divided by 2 is 22. So we reduced everything by 2, and so our answer, once we do that, is 3 minus 6 root 3 over negative 22. I am completely fine with this answer, just to let you know, so you're not taken by surprise if you ever see it. Some books or texts don't want a negative in the denominator, so what they'll do is they'll multiply by a form of 1 again. They'll just multiply by negative 1 over negative 1, which changes all the signs. So up here in the numerator, if you distribute, you would get negative 3 plus 6 root 3 over a positive 22. So either of these answers are okay, which notice the difference between them is all the signs are opposites. This is positive 3 and negative 3, negative 6 root 3, positive 6 root 3, negative 22, positive 22. So either answer is fine. Going to number 14, once again, two terms. So we're going to multiply by the conjugate, which we change the sign in the middle. So 3 minus 4 root 2 over 3 minus 4 root 2. And once we apply that concept, we just kind of follow the math. We do what we're supposed to do. We multiply, simplify, and we'll get our answer. So distributing this 2, we get 6 minus 8 root 2. So distribute the 2 to both of those terms. In the bottom, we multiplied a number times its conjugate. So it is going to be the first number squared. So 3 squared minus the second number squared. Put it in the parentheses just to remind me I have to square both of those. And so we have 6 minus 8 root 2 over 9 minus 4 squared is 16. The square root of 2 squared is 2. 16 times 2 is 32. 9 minus 32 is negative 23. That's what will be in the denominator. And we have 6 minus 8 root 2. 23 is prime, so it's not going to reduce with either of these in the numerator. So there's our answer. And our last slide with the last two questions. Going to be the same concepts to start with as before, and then we'll just kind of follow the math as I mentioned. We do have 2 square roots, but that's okay. We have a square root of 5 and a square root of 2. We still apply the property or the concept that we're going to multiply by the conjugate. So this time it's a negative. Again, we don't want square roots in the denominator. That's why we have to do this. So we're going to multiply by 2 root 5 plus 5 root 2 in both the numerator and denominator, because we're just then multiplying by a special form of 1. Now we have to do multiplication up top here. 2 times 2 root 5 is 4 root 5. 2 times 5 root 2 is 10 root 2. And now negative 5 times 2 root 5 is going to be negative 2, but root 5 times root 5 is simply 5. And then root 5 times 5 root 2, again it's negative, so we'll put negative, and this is going to be 5 root 10. So that's the numerator. In the denominator, we're multiplying a number by its conjugate, so it's going to be the first thing squared, so 2 root 5 squared, minus 5 root 2 squared. And now we just need to do some simplifying. 4 root 5 can't simplify. I'll leave that as is. 10 root 2 cannot simplify, so we'll leave that. We got negative 2 times 5 next, which we know is negative 10. And root 10 does not simplify, so we have negative 5 root 10. Just looking across here, none of these are like radicals, so we're not going to be able to add any of those together as we keep moving forward. First number squared, so 2 squared is 4, and root 5 squared is simply 5. And then minus 5 squared is 25, times root 2 squared is 2. So if you just want to write this here, this is 20 minus 50, which is negative 30. So we can write our next part, 4 root 5 plus 10 root 2 minus 10 minus 5 root 10 all over 20 minus 50 is negative 30. We have a negative 30 down here. We want to see if it reduces. The thing that reduces with 4 and 30 would be 2, which does reduce with 10. And 10, but 2 doesn't go into 5, so we can't simplify this anymore. So there's our answer. Once again, I'll mention again, sometimes texts or answer keys don't want a negative down here, so they'll multiply top and bottom by negative 1, which in turn changes the sign of each term. So if you see an answer that said negative 4 root 5 minus 10 root 2 plus 10 plus 5 root 10, that's a terrible 10, all over positive 30, it's the same answer. And our last one for the review, we will once again realize we can't have square roots in the denominator. Also, I'll mention we can't simplify root 2 or root 5 or root 3. Nothing simplifies there. So we're going to multiply by the conjugate over the conjugate. So again, it's a negative, so we put a positive. And really, we're just multiplying by a form of 1. Multiplying up top here. This is, we can get everything in here, 4 times root 5 plus 4 times root 3 minus, we got a minus here, root 2 times root 5, so minus root 10. And then our last one, negative root 2 times 3 is negative root 6. In the denominator, we multiplied a number by its conjugate, so it will be the first thing squared minus the second thing squared. None of these are like radicals. In fact, none of them can simplify either. So the numerator stays as is. And the denominator, root 5 squared is 5 minus root 3 squared, which is 3. 5 minus 3 is 2. Does 2 simplify with each one of these terms? It does not. It goes into 4 and 4, but these just have 1's out here, so they don't simplify, and we cannot simplify something not in a square root with something that is in the square root. So that is the answers for all of the review for 7.4 and 7.5. Please be ready for this quiz.